In figure, tangent PQ and PR are drawn to a circle such that angle RPQ is over here, guys, is equal to 30 degree. That's good. A chord RS, so this is a chord, is drawn parallel to tangent. This is parallel to this. Just a second. So these two are parallel to each other. Then what else do we have? Find this particular angle. Okay, so there's a hint. We need to draw a line through Q perpendicular to basically this line, guys, from the radius, joining O, and let me use this color and this size. So we're joining this and we'll join this also. See, by default, what do we have? We have ORPQ to be a cyclic quadrilateral. What is a cyclic quadrilateral? Wherein the opposite angles add up to 180 degree. Why is that? See, this is 90, tangent and radius. This is also 90, tangent and radius. These two need to add up to 180 degree. Is it not? So end of it, the math will tell that this is how much? 150 degree. Okay. So next we have RQ to be a chord. So we have a chord property which is somewhere over there. Please figure it out. It's there on the screen. Yes, we are looking at this. Please read through this. So what do we have? We have an angle subtended by the arc, if not the chord, with the center to be double that with respect to the circumference. So basically, if this is 150, this is 75 degree. Okay. And next is, see, these two lines are parallel, making angle, let me clear it up actually. Don't worry, we will write all of this. Now, this we figured out to be equal to how much? I think 75 degree, right? See, we have to figure out this angle, is it not? So using triangle PRQ, we'll be able to. So we need to know this angle as well to help us out finding SQR. How will we find that angle? Using the fact that these two lines are parallel. How will that help? Well, first thing first, in triangle PRQ, we have these two sides to be equal. The reason being tangent from an external point are of equal length and so on and so forth. Right? So basically these two angles are equal. Because those two angles are equal, this is 30, these two angles will be 75, 75. So this two also will be 75. $75, 75, 150. So this will be 30 degree. That's so weird. This is also 30, that is also 30. Okay. So yeah, this needs a lot of writing. That is still there. So let's start writing. First thing first, your answer needs a diagram. So we need to join these two lines to help us figure out angle S. So we need to talk about that. Join OR and OQ. Okay. Then we have, what else can we tell? That's it, I guess. No other construction. Oh yeah, this is parallel to this. We'll mark that also. Then we have to find, right? So let's start with the working. First thing first, we'll consider what in quadrilateral ORPQ. This being O, by the way. So these two lengths are equal. I mean, that's not required actually. Anyways, doesn't matter. So what do we have? Angle P plus angle OQP plus angle QOP plus angle ORP. All of this is equal to 360 degree. Angle sum property of a quadrilateral. Angle sum property of chord. And next we have angle P is 30 degree. This is 90 degree. This is an unknown. This is 90 degree and this is 360 degree. Okay. The reason being radius is perpendicular to tangent, right, at the point of contact. At the point of contact. And so this will be angle QOP is equal to 180, 150 degree. Directly you can write, you need not show more than this. This is good enough. And now on to writing that angle QSR is equal to half of angle QOP. So this is 75 degree. But why is this? The reason being chord QP, or a chord, in this case QR not P, subtends how do you put it, an angle double, which is double at the center, which is double that of an angle subtended by an arc at the center, subtends an angle at the center which is double the angle subtended by it with the circumference. Again, you can change the language. At the circumference. Okay guys, so we found this to be 75 degree. So angle S is 75 degree. And now on to finding angle, this particular angle. Okay, we are almost there. So first we will consider triangle. In triangle QRP. So here PQ is equal to PR, because they are tangents from the same external angle. Tangents from same external point. And so we have angle PQR is equal to angle PRQ, which we can call it as X or something, that's okay. Then we have angle sum property, angle PQR plus angle PRQ plus angle RPQ. All of this is equal to 180 degree. You don't have to write the reason, we already written such reasoning. Okay, and then we have, let me just change the presentation a bit. Yeah. And then we have 2 times of angle PQR is equal to 180 degree minus 30 degree. This is because of 1, but we have 2 over there. And so this will be angle PQR is equal to 150 degree by 2. That is 75. We can directly write this as well. So with this information, I can also tell that what angle SRQ is equal to angle RQP, as we have SR being parallel to QR, QP, and these are alternative interior angles. So therefore we have angle SRQ is equal to 75 degree. And at last we have in triangle SQR, right? Angle SQR is equal to 180 degree minus angle SRQ minus angle QSR. And so this is equal to 180 minus 75 minus 75. So this is 30 degree. That's it. And we have the answer. Right? RQS only. RQS. Yeah, that's correct. Okay, so yeah, this is actually, let me change it to level 3. There's a lot of thinking, a lot of writing to do as well. This is a difficult question. Okay, so you need to know a lot of concept, and all the concept again are over here and over here. Take a print, make use of it. It will be helpful. 75, 75. Okay, so this is your answer.